Hey, how's it going? I got another NestJS tutorial for you today, this time with GraphQL. So this tutorial is going to be split up into a couple core parts. First, we're going to talk about how to generate a project from scratch and how to set it up so that it works with a GraphQL schema, how to write your initial resolver. The second part is we're going to talk about how to integrate this with a database using TypeORM. And then finally, the last part is all the things that we can do to make it all even better. So for example, validation, how can you auto-generate a bunch of this stuff, as well as how do you work with database relationships and how to do that with TypeORM and GraphQL and NestJS kind of working together. So what we're going to build today is a pet store API. So imagine if you had a client who had a pet store website of some sort and they need to be able to query who are all of the pets, who are the owners of those pets, as well as having the ability to add a new pet, a new owner, and so on. By the way, I do kind of assume that you have a little bit of background in terms of what is NestJS. If you don't, I have an older video where I compare Express and NestJS. If you check out my channel, it's also good to have a decent background on GraphQL itself. I don't really talk too much into detail of what it is and what are all the different parts of it. The main thing that we'll focus on today is queries and mutations. So if you have a basic understanding of that, as well as arguments and input types, so that would be a really useful background to have. The documentation on graphql.org/learn is a very good place to start reading about this, even if you haven't looked at it before. And then TypeORM, which I mentioned, is what we're going to use for our database integration. This one, if you don't know as much about it, that's fine. I think I will have that covered in the tutorial. But one thing that would be really useful to know about is the repository API and how that all works. So that's the main thing that we're going to be using with NestJS. All right, finally, let's jump right in and let's get started. So just like with any NestJS project, you're going to want to have the CLI installed. So you can do npm install -g at nestjs/CLI. I already have this installed, so I'm not going to show that, but there's a script if you need to copy it. Once you have the CLI installed, you can then just do nest new and then the name of your project. In our case, I think I'm going to call this Nest GraphQL demo. Hit enter, and then it's going to ask you what package manager you would like to use. I usually pick npm here. You can use yarn if that's something you're more familiar with. And when that's finished installing, we're going to go right into that directory. And then we're going to install a couple other things. So our core GraphQL dependencies, npm install, and I'm going to paste a bunch of things in here. So feel free to pause the video, and if you're following along, just copy that. But as you can see, what we're really installing here is GraphQL itself, as well as the NestJS sort of integration package between the two. And then behind the scenes, we're actually just using Apollo server, which is one of the nice things with NestJS is behind the scenes, at least by default, it's still using Express. So in theory, anything that you can use with Express, you can still use with NestJS. So let's install that, and it shouldn't take too long. Okay, now that that's finished installing, I'm just going to open up a Visual Studio Code editor from here. And you'll notice what our CLI, Nest CLI generated is just a bunch of kind of starter files for us, a basic controller, a root app module that we'll be working with a lot. So the first thing we're going to do is in the terminal here in VS Code, we're going to again utilize the CLI to generate our initial pets module. So you can do nestg, G is short for generate, nestg module pets. And you'll notice as I run these generate commands, it automatically updates my files to wire it up correctly. So notice that the app module now has a pets module import. And then if I open up that pets module, as I add more things to this module, you'll also see that this is going to be automatically updated. So for example, we're going to do another nestg service pets, and then one more thing, we're going to do nestg resolver pets. All right, now we got our basic pets module generated with a service and a resolver. We're actually going to go back to the app module. So what we're going to add here is the import for the GraphQL module. This is the thing that's gonna kind of make it all work, and make sure to add any missing imports. So before we move forward, let me talk about this line 11 really quick. If you go to the NestJS documentation for this GraphQL integration, you'll notice that they talk about the option that you can either go code first or you can go schema first. What this effectively means is if you go code first, what that means is you first write your TypeScript classes, and from those TypeScript classes, NestJS will try to figure out, all right, what is the schema, and I'm gonna auto generate that for you. So hence, that's why there is an auto schema property that says it's gonna generate our GraphQL schema into this file. So you're writing the code, and the schema, the GraphQL schema, is auto-generated from that, hence code first. The schema first is kind of the inverse of that, is if you're someone who already knows GraphQL really well and you know how to write the schema yourself, you can instead take the inverse approach of you write the GraphQL schema first, and that schema is going to auto-generate the TypeScript definitions that Nest will need to kind of run throughout the application. In this tutorial, we're going to stick with the code first approach, and that's for a specific reason. Since we're also going to be using TypeORM, in TypeORM, usually you create classes to represent your database entities. So for example, if you had a user database table, you're also going to have a user entity class. That means we already have these classes that represent the schema, so we can use this class to also generate our object type for GraphQL. So what that effectively means is we can write one class that represents both our database schema as well as our GraphQL object types. So in our case, it's not really worth it to go schema first. However, you can go that route if that's something you're more familiar with. All right, so back in the code, again, make sure you have this GraphQL module for root with the auto schema file. So since we just talked about entity classes, let's go ahead and create a new file in the pets directory. We're going to call this one pet.entity.ts. And we're going to start with a basic class, export class pet. And within this class, we're going to define the properties that we're going to have, again, both in our database as well as our GraphQL schema. So usually when you save things in a database, you're going to want to have an ID. We're going to keep it simple. We're just going to have number IDs. And then pets usually have a name. Make that a string. And then maybe there's an optional type property. For example, maybe the pet is a dog, a cat, a lizard. All right, so right now it's just a basic class. The way you kind of tell Nest and GraphQL that this is an object type is by adding the object type decorator. Okay, and you'll see that got imported from this package. And then you also have to tell GraphQL which properties of this class is going to be part of the schema. So you need to add field here. Another decorator, and then within this decorator you can specify what type it will be. In this case, numbers will be represented as the int scalar type from GraphQL. Like I said, I'm not going to go over the documentation too much, but there is a section here where it talks about scalar types. So that int that we just imported is this representation of a 32-bit signed integer. Now with strings, it's a little bit easier. It seems to automatically be able to know that this kind of string is just your regular string in GraphQL, so nothing to do there. And then same thing for this guy, except we need to add a configuration object here to say that this is nullable. I think that's a TypeScript limitation where it's not able to communicate that just because it has this question mark over here, it doesn't know that it's nullable. So you still have to tell GraphQL, hey, this is optional. So now that we've got our pet object type, which you'll see this generated in the schema in a little bit here, let's go ahead and try to create a new query to perhaps query all of the existing pets in our system. So within PetsService, let's maybe create a mock findAll method, which returns a promise of PetsPet. Okay, and we didn't set up our database integration yet. We'll do that in a few minutes here. So we're just gonna kind of mock it out. So maybe we have a new pet that has an ID of 1 and a name of, let's call it Mambo. All right, and we said we're gonna return an array of these, so our mock implementation could just be returning an array with that one pet inside. And we said it's a promise, so let's make this async. All right, we're gonna enhance this a little bit later to make that more real, to actually talk with the database. But first, we just want to make sure that we can kind of show how to wire all of the things up and be able to generate that GraphQL schema. So now let's switch over to our pets resolver, where I'm going to add a constructor so that we can inject our service in here. Private PetsService has a type of PetsService, right? And again, if you're not super familiar with NestJS, what Nest is gonna do kind of behind the scenes is it's automatically gonna create an instance of that PetsService and then inject it into our resolver here. So let's go ahead and write our first query. Maybe this was just called pets, and again returns a collection of pets, and this will just do our this.PetService dot the thing we just made earlier. Make sure to import our entity, and then the thing we need to add to actually tell the resolver that this is an actual query is the query decorator. You'll notice with NestJS and all this stuff, everything is kind of based on adding the right decorators to things. One thing to call out here is make sure you're importing query from the correct place. So for example, VS Code actually imported it from the wrong place from me. I don't want this query from NestJS Common. I want that query from NestJS GraphQL. So that's a very easy mistake to make. So make sure you're aware of that. With this, the GraphQL query, what you want to provide in here is the return type. So it's expecting a function that returns the type that you're expecting. In this case, it's going to be an array of pet. And notice that the syntax here might be a little bit weird, right? Maybe you're expecting to write it this way. Just know that you got to write it like this, because you'll notice later when we generate the GraphQL schema, that's how GraphQL represents arrays or lists, is they have kind of the bracket and then the type within that. And then one last thing before we get this to work is on the resolver, you also almost always want to add a type here as well of what is this resolver for, right? It's resolving for pets. So I'm going to add that, and that's going to also be useful for later on when you're having nested fields, nested queries. All right, now that we have all that set up, that kind of concludes the first core part that I mentioned for this tutorial. Let's go ahead and run npm run start dev to finally run our application for the first time. So if you did everything correctly, you should be able to see that it'll say application successfully started. You shouldn't see any errors or anything in here. All right, now when you see that message, you can go ahead and switch over to your browser and go to localhost 3000 /GraphQL, and you should see a playground there. And you'll notice that if we go to the schema here, you'll notice that it's seeing a pet schema, our object type, as well as the query we just made. Actually, really quick, back in the code, you should also see that new schema.gql file, which has that schema, right? So our auto generation of the schema is now working. And let's go ahead and run a test query here of our pets. And within that, we just want to grab back maybe the name. And we should be able to see Mambo because we hard coded that into the response. All right, so there you go. That's kind of the first basic part that I wanted to cover, is how to kind of set it all up, get your basic schema working, and get a resolver working. The next part we're going to cover here is our database integration with TypeORM. So we're going to do npm install at NestJS /TypeORM, and also the TypeORM package itself, and then our database driver. In this case, I'm just going to use SQLite. SQLite is just kind of really easy to set up and get up and running for basic development. You can, of course, use your own preference here. Like if you have a MySQL or a Postgres database, you can do that as well with TypeORM. TypeORM even has support for basic support for MongoDB if you want to do that. So I'm going to hit enter here and wait for this to install. All right, so that just completed for me. I'm going to go over to our root app module.ts, and I'm going to add a new import here of this. So I just pasted this in, but basically you need a TypeORM module for root at your root module, and then within that you just provide the configuration object that you pass on to your database driver. So if, for example, if you were using MySQL here, you would pass in your your MySQL host and password and so on. So over here we have the type of SQLite, like I said, and then we also have memory here. What that means is it's going to run our database in memory. So as it restarts, it kind of starts from a fresh database. And then this field just says where is it going to find our entities. Basically, it's going to look for any file that has .entity in the file name. So that's why our pet entity has that in its name. And then synchronize through just means that it's going to automatically synchronize our database schema. So for example, if we were to create a new users entity, it's going to automatically add that as a new database table. So it's going to make it so that our database always matches our schema on the fly. It is worth noting that in production, you should not be using synchronize. You should instead use migrations, which TypeORM also supports. So again, this is really just it's an easy tool to have for development or demos like this that we're doing. All right, now that we have our TypeORM module configuration in place, we can go back into our entity, and we said that we can reuse this class to represent both our object type in a GraphQL schema as well as our entity in a database. So this is the primary reason we're doing the code first approach. So I'm going to add an entity decorator here from TypeORM, and then similarly I'm also going to add decorators for the fields so that we can tell TypeORM in the database what are these fields. So for example, I want this to be a primary generated column, which will just communicate to SQLite that this field needs to be an auto incrementing integer. And similarly with this one, for the name, we just need to have a column here. Nothing really to configure there. Again, it's kind of the same where if it's just a string, it knows to turn that into a varchar in a database. Same thing here. Again, similarly, we also need to tell it that it's nullable. So in the database representation, this means that this column in the database to type is nullable. This one, the name, is not nullable. So in the database representation, it's going to be not null. So it's going to require that you provide a name on every insert. All right, so again, now our entity is set up to represent both our database table for pets as well as our object type for the GraphQL schema. So that's really useful in my opinion. So let's switch back to the pets module, and we're going to add a new imports here. which is the other TypeORM module again, but this time we're going to do for feature, which takes in an array of entities. In this case, we're going to do pet. And if you're not familiar with this, what this import allows us to do is then within our pet service, you can add a constructor here which has the inject repository of type pet, and we're going to call that the pets repository, which also has a type of repository pet. Okay, so the only way that you're able to do this inject repository is if you had this TypeORM module for feature. So you have to make sure that whatever repository for a entity that you're trying to import, that needs to be in this array. And again, I kind of briefly mentioned it in the beginning, but it would be really useful for you to know the repository API in TypeORM. So take a look at that in the documentation. But let's go ahead and just show you some example usage. So now that we have that, maybe let's update this find all to be, the real thing. So we're going to change this to this.pets repository.find. So by default, what find does is effectively the same as like a select star from your database table. All right, so now that we've got this basic find all, if we go ahead and rerun our npm run start dev, back in our browser, if we run our pets query here, now we get back an empty array. And that's because it's actually going into our SQLite database and saying select my pets, and it's not getting anything. So again, to make that a little bit more real, let's go ahead and implement a way for us to perhaps add a new pet to our database. So we're gonna do createPet as a new method, and I'm gonna provide an argument here that I'm gonna explain a little bit more in a sec. So I'm gonna call this createPet input, and this method returns a promise of a pet. And basically, so imagine that createPet input is our DTO, our data transfer object, which has the fields that we need to create a new pet. So in this case, probably gonna need a name and an optional type. So just imagine that's gonna be what that is, and we'll define the shape of that in a second here. But first, we're gonna do const new pet equals this.pets repository .create, and then we pass in that input. And what this is effectively kind of the same as doing new pet equals new pet, and then you go into your new pet dot name equals your input dot name. So that's kind of the shorthand for that, is instantiating a new class and setting the different properties. And then once we have that, we're just going to return this.pets repository.save that new pet. So again, you can look at the documentation if you want on what save does, but effectively this is the insert into the database. And save can also be used for updating. So if you have an existing entity that you queried and you made changes to it, you can save those changes using save. So right now it's doing a squiggly line here with the red. That's because it's not able to tell what the shape of this input is, so it doesn't know if it's correct. So what we're gonna do is within our pets directory here, we're gonna create a new folder. We're gonna call that DTO. And within that folder, we're gonna create a new class called create-input createPet.input.ts. And in here, we're going to create another class called createPet.input. And this class is going to contain those fields that we're looking for. So again, like we said, we want a name here and an optional type. Now, kind of similar to our entity file, what we're going to do here is we're going to decorate it with an input type. Okay, and input types in GraphQL, again, I'm going to point you to the documentation here if you want to check it out if you're not familiar with it. But input type, it is an actual thing in GraphQL that basically just represents your DTOs. That's basically what they call data transfer objects in GraphQL, is input types. So it's a representation of the shape of an object argument or input, hence the name input. Again, we need to add a field decorator here and another one here, and this is kind of the same as like the field that we provide in the entity, right? So same thing, if it's a number, make sure to do this, the scalar int. If it's another class, you need to specify that. In our case, again, we need to make this nullable. All right, so now that we have that defined, we need to fix our PetsService.createPet to have the right type here. Make sure to import this. All right, so now all the red squigglies are gone. Our application started up again, and that's because it now recognizes that, oh yes, this is a valid shape for a new pet. All right, now that we have all that out of the way, we can then create our first mutation, which is creating a new pet. createPet, and that takes in a create pet input. Keep messing that up. And similarly, this returns a promise of your newly created pet. Okay, and this is really just calling PetsService .createPet, and we're just kind of forwarding that argument. Now, if you're kind of following the pattern here, we got a couple of things that are missing to notify GraphQL that this is actually a mutation. So kind of similar to how we have a query up here. In this case, we're going to add mutation, which returns a type of pet. And then one last thing is we're going to add args here. And this takes a string that we're just going to also call createPet input. So let's take a look at the schema on what that generated. If I open this to the right here, you'll notice that we've got our new mutation that has createPet, same name here, and then the name of the argument here is actually the name that you pass into the string. So that's why we kind of just keep it the same, you know. So for example, if I call that test, you'll notice that our schema gets updated to have test here. So that's why you generally want to keep that to be the same. Okay, now we can go back into our browser, into our playground, and let's go ahead and test our new mutation. Do mutation and then create, and you might need to refresh, by the way, so it can pull in the schema. createPet, and notice that the argument here is createPet input, and we want to provide that with an object that has a name, at least Mumbo. And then the return schema, we're also gonna do name and ID. Right, so when I ran that, now it has Mumbo created, and just to kind of verify this is working, it's saving in our database. If we go back to our pets query, if I run that, we get Mumbo, right? If I do another one here, Dumbo, and run our query again, now you got two things, you got Mumbo, Dumbo. And again, notice that our ID is incrementing, right? Because we have that primary generated column annotation in our entity. All right, so that's the basics of how to do mutations. You might be wondering, why did we have to go through kind of the effort of making these input files. And there's another benefit to doing it this way, because you can kind of just inline define your input shape in here, but having it into a specific input type like this then allows you to do things like auto validation in the future. So for example, NestJS has really good integration with class validator to do validation. So actually, why don't we go ahead and show you a simple example of that. What if we, for example, wanted to add some validation on what the name should and shouldn't be. So in the terminal here, I'm going to do npm install class validator and class transformer. All right, install that. And once that's installed, switch over to our main.ts file here. And this is where you can define global pipes. And pipes are one of the concepts in Nest that you can use to do things like validation or object transformation, input transformation. So we're going to add app.use global pipes, new validation pipe. Now what that allows us to do is we can then go back to our pet entity and we can do something like, go back to our createPet input, and then we can do something like, maybe we want to make sure that the name is only alpha. So in class validator, you can add a annotation called is alpha, right? You see it's coming from class validator, and this sets it up so that you can't just provide non-alpha names. So let's go ahead and test this. Back into our playground, if I go to createPet, and if I were just to provide a set of numbers here, it technically is still correct from the schema's perspective because it is still a string, right? Because we have it wrapped in the quotes, but it's not alpha, it's not letters. So when I run this, it's going to come back with a bad request exception, and you'll notice because message name must contain only letters, right? So now we've got validation working just from a simple annotation on our input class. So that's why having the input class in its own definition like this is very nice, because then you can add specific validations in it, and you can go into the class validator documentation and you can look in here in the validation decorators. There are a bunch of stuff in here, like for example, you want to have like a date string. Is it positive? Is it negative for numbers? Min and max. You can specify your lengths. You can say, is it alphanumeric? Is it just numbers? Is it a number? So basically there's a lot of really useful kind of predefined validation that you can take advantage of here. And all you have to do is specify it as a decorator on your classes. So that's really nice. And really quick side note, this is one of the things that I really like about NestJS is everything just feels cohesive. Like everything that you're doing is sort of just writing classes and adding decorators to it. So there's one cohesive way of defining and creating things, and to me it's really nice. For comparison, if you're doing this in Express, if you weren't doing it in TypeScript, right, then you won't have access to decorators. So in those cases, you're probably going to be representing your database classes a certain way. You're probably going to be doing a different schema language for your validation, like if you've ever used Joy or something similar. Again, in Nest, it's just really nice and cohesive in my opinion. All right, so that's a quick example of validation. And just to add a couple more examples of writing queries here, maybe let's write a query for being able to select just one pet, maybe by ID. So let's maybe add in our PetsService a findOne, which returns a promise of a single pet. And in here, we're going to have an ID, which is a number. And this is simply return.this.pets repository.findOne or fail. You want to use findOne or fail here so that it actually, assuming you want it to fail if it didn't find the pet that it's looking for. If you just do findOne, it's going to return an empty array if it didn't find anything. So most cases that I found, you usually want to use findOne or fail, and then you just pass in the ID here. All right, and then within our pets resolver, we can add a new query here. Maybe let's call that getPet, and similarly, this returns a promise of a pet. And we're just gonna do this.PetsService.findOne and pass in an ID. In this case, you can, like I said, you can also define your arguments kind of in line here. You can do args and then provide a string for the name of that arg. We're just gonna call it ID, and then you're gonna have to provide a config here so that it knows what type that is. Again, we're gonna do our scalar int. We're gonna call that ID, and it's a number. And then pass that down here. Anyways, same thing here, query returns pet. So let's go ahead and go back to our playground and test that out. Remember that I said our database is running in memory. So every time I'm changing the code, it's actually emptying out my database. So if you run pets right now, it's going to be empty. So we're going to have to do a createPet first. And again, we got to have an alpha name here. Maybe you're smart and you just, did the string version of the number. So let's do 11, which has an ID of 1. So if we now run our new get, again, let me refresh this. So it gets the new schema, get pet, and that takes in an input of ID. And I'm going to provide 1. And I want to select the name. If I run that, I should get back 11. All right, so there you go. There's another example of a query. If you're still with me here, the next thing I want to cover is what are some of the shortcuts that you can do to generate a lot of this stuff for you in as little time as possible. So I walked you through kind of doing a lot of this from scratch because I think it's important to know the fundamentals, right? You should know how to write this from scratch if you had to. But once you kind of understand how to set up your entities and your input types and your annotations for queries and mutations, once you know all of that and you're pretty familiar with, then you can in the future just use the NestCLI to auto-generate a lot of the boilerplate for you. So let's go ahead and take a look at an example for that. So as an example, let's imagine that we're going to add another thing to our schema of type owner, right? Every pet needs an owner. With the NestCLI, you can do something like NestG resource and then provide it with a name of your resource. In this case, we're going to do owners. And when you hit enter there, you'll notice it's going to give you a couple options here. Since we're doing GraphQL code first, we're going to select that. And it's going to ask you, would you like to generate CRUD entry points? So this is basically a boilerplate generator for CRUD stuff. We're going to go ahead and select Y here so you can see what this generates. And again, notice that it generated a lot of those things that we kind of did from scratch, right? It's got a new module, a resolver, a service, and a couple DTOs as well as the entity. So let's take a look at those. So notice we now have a new owners directory here, and it's got a resolver that has basically all of the CRUD stuff there by default. Like it's got create, it's got find all, find one, and then update, delete, right? Your basic CRUD. And it's got everything wired up for you. So again, this is really nice if you kind of understand how to write these things from scratch already. It's going to save you a lot of time. The one missing piece here is if you go into the owner service, you'll notice that they all just return strings, right? Because it doesn't know how to hook it up to TypeORM. So that's the only thing that's missing. So we'll fix that in a little bit here. But let's take a look at the entity that got generated. So again, it creates your object type for you. And similarly, there is an input type for creating and updating. All right, so back in the owner entity, why don't we go ahead and turn this into kind of the real thing? So let me just delete this. What we're gonna do here is kind of similar to our pet entity. We're gonna turn this into a database entity, and we're gonna add an ID field here. Same thing with the number. And actually, just to save some time, let's open up our pet entity and just copy this part. Sure, let's also give this owner a name. Import these missing decorators. All right, so now we got a new owner entity that has an ID and a name. Let's go ahead and set up some database relationships. So owners should have, pets. So let's define this real quick. From a database perspective, this is going to be a one-to-many, right? An owner can have one-to-many pets. And within here, we need to provide a little bit of configuration first, kind of similar to, these field decorators. We have to tell a TypeORM or database what is the type of this field. We're gonna do pet, and then we also need to say in the pet where is the kind of matching field, right? Where in this case it needs to be pet.owner, and this is gonna be red squiggly because we haven't implemented that yet. So we'll fix that in a second here. But don't forget your GraphQL annotation, kind of similar thing. It also requires a function here to specify what the type is. So in our case, it's an array of pets, so it needs to match this type. And we're gonna say it's nullable because maybe initially you don't have any pets. On the other side of that, we're gonna do, in the pet entity, we're gonna add an owner field of type owner. So this is the inverse. So this is gonna be a many-to-one. So similarly, we need to provide the type as well as within that object, what's the property that it kind of maps to. So in this case, the thing we just defined was owner.pets. Right, so this is kind of saying in this entity, owner.pets maps to that relationship, and pet.owner maps to this, right? So it's kind of a lot. It's like, how do I explain this? Like the field has to exist kind of as a bridge between the two entities. That's a terrible explanation, but can't come up with anything better right now. And again, we'll add a field here, and this should have a type of owner. So with these many-to-one and one-to-many annotations, the way it works is when the schema of the database updates, it's actually gonna behind the scenes add an owner ID to the pet table, and that's how it's gonna be able to do the relationships. So if you were, from a database perspective, if you're trying to find the owner of a pet, you can do the join from, select pet, and then inner join on owner ID equals owner.id. So behind the scenes, there is a new owner ID column that's being added to our pet table. You can also specify that here if you want to have access to it, which we do later, as you'll see. So I'm gonna do column and field here, and it's gonna have a type of int, scalar int. All right, and I think we need to also update our owner DTOs here. We're gonna copy this name. So the create, really, this should be a name, just a field. All right, so now that we kind of have those relationships in place, what I want to be able to do is in our query, I want to be able to do something like get all of the pets along with their owner. So if I were able, ideally, I want to be able to do something like this, like who is the pets and who is the owner of each of those pets. So that's what we're gonna implement next. So before we can do that, we need to fix some stuff in our owners module. Again, to kind of make it real, we need to add our TypeORM module for a feature here, and it needs to have access to the owner repository. Imports, that's another easy thing to mistake. All right, and then within owner service, we can add a constructor where we can do our inject repository again. Add any missing imports. All right, and then let's go ahead and implement some of these missing implementations. So for example, I'm going to leave update and removing. Maybe that's something that you as a viewer, maybe if you're following along, you can implement that yourself as a practice challenge. Okay, so if we go back to our resolver, that means that we can now do a create owner mutation, and we can also do a find all owners and find one owner, and these two does not work yet. One thing I want to call out real quick is, again, notice that we have a findOne implemented in an owner service. We actually want to be able to share this method with our pets module, so that, again, we want to be able to find the owner of each pet. So to do that, in NestJS, you can have providers be shared if you add it to the exports array here. And we're going to do owners service. What that allows us to do is we can then go into our pets module and add this as a new import here. We can do owners module, and what that allows us to do is if we go into our PetsService, we can add a new import here of owner service, and that means that now we have access to those methods in the owner service. So maybe we want to implement a get owner here, which takes in a owner ID and returns a promise of an owner. So we can do return this dot owner service dot find one, and we're going to forward that owner ID. And don't forget to import your owner entity. All right, now that we have that in the pet service, we can then go back to our pets resolver, and we can add a new query here for owner, which returns a promise of an owner. And we're going to do return this dot pet service dot get owner, and we need to pass in some kind of ID here. And one thing that we can add here is a parent decorator for pet, and then you can do pet dot owner ID. Don't forget to add your query. Actually, this one should be called resolve field, returns a type of owner. All right, so let's talk about this a little bit because I just typed a bunch of stuff there. The parent here is something that you can use for, if you think about it from a nested query perspective, right? So for example, what we're trying to do is here, the owner of kind of this sub, if you think about it as like a sub query, the owner of that, the parent of that is this pet object up here. So we want to be able to pass this ID down into that query. So that's kind of what that parent is doing, is it's grabbing the current pet that you're on. Let's pass down the owner ID of that. And again, we have access to that owner ID because we added it to our owner ID here in our pet entity. And then resolve field works again because that's kind of we're saying we're resolving this kind of nested field. So it's kind of like I could think of it as like a way to define like nested queries. That's what resolve fields are for. And this is also really important. This is why we needed this of pet. This is what enables us to do this resolve field with a parent of type pet. All right, now that we have all that in place, there's actually one last thing that I want to make sure we don't forget. In the createPet input, we need to add the new owner ID number field here, which is not nullable. And this is so that when you, at the point that you create a new pet, it's going to require that there's an owner, right? In a real case scenario, you don't want to be able to add pets and not know who their owners are. All right, so with that in place, we're going to go ahead and run npm start dev again. And once that starts, back into our playground. Again, remember that our database is getting wiped each time because we're doing it in memory. But in my case, I need to do a create owner first, right? Because now you can't create a pet without the owner. And this requires an input of at least a name. I'm just going to provide my own name there. And we're going to select ID and name. All right, so there's me as an owner with ID 1. Now in our create pet, we can enhance this to pass in the owner ID, which is 1. So this is me saying I have a pet whose name is 11. So let's run that. So now we've got a new pet created. And if we go into our pets query, right, we were saying that we want to be able to query pets along with their owner. So if we run this, now you've got kind of that nested relationship happening in our query. You're able to query your pets along with their owners. All right, so that's pretty much it, really. That's what I wanted to show in this tutorial. You, of course, can also implement the inverse of that, of being able to query from the owner side, be able to query their pets. Like maybe you wanted to do something like owners, and for each owner you want to pull the name and their pet's name, right? So we didn't implement that, but that's something, if you're following along, again, I would challenge you to try and implement that yourself. And then we also didn't implement update and deleting to kind of complete the CRUD. Again, I'll leave that up to you as a challenge. All right, so that's it, guys. That was kind of a long tutorial. Hope you found some value in that. I would definitely appreciate any feedback that you might have. Let me know in the comments, and a like or a subscribe or both is also highly appreciated. It helps YouTube tell that this content might be useful to be found by other people. And with that said, I'll see you in the next video. Thanks.